Hi guys, welcome to CS50 Substitutions Walkthrough Tutorial Hints and Clue. So today we'll divide into 7 sections: substitution programs, pseudocodes, get keys, validate keys, get plaintext, Encipher, and also print the ciphertext. So a program will consist of 3 parts: substitutions, the keys here, the plaintext, and ciphertext. You can see here the plaintext is uppercase, and the ciphertext will also become uppercase regardless the key. The key is currently uppercase, so you can see both are the same case. So a lowercase with lowercase, a mixture of uppercase and lowercase, and the non-letters. So for example, the user key in this is CS50 that consists of uppercase, lowercase, and also non-letters. So you can see the ciphertext is fully equally same case, and non-letter will be the same, no changes. So we can conclude here that the plaintext letter case is equal to the ciphertext letter case. So as for the keys, we can divide into different types: the uppercase keys, lowercase keys, and also the mixtures of upper and lowercase. So for example, if the key is uppercase, you can see the plaintext and ciphertext is the same. So if the key is lowercase, the plaintext and the ciphertext is also the same. If the key is a mixture of uppercase and lowercase, the plaintext is also the same. So as we can conclude here, the key letter case will not affect the plaintext and ciphertext letter case. So before we go to the next sections, we have to understand what is Argc and argv. So to use this, we have to include the CS50.h. So these two argument count and argument vectors. So argc is actually argument counts, the number of arguments passes to the programs. Argv is argument vectors, one-dimensional array of strings. So for example, this is an example here. So we can see here there's a 4 argc, which means there are 4 arguments. So the arguments we can use to show one by one, which is /substitutions 1, x, and z. We can also divide them into indexes. So index 0 /substitutions, this is 1, 2, 3, 4. So from our computer science, our 1 always start from 0. So to see here is much more clear. So argv index 0 is substitutions, 1 is 1, 2 is x, 3 is z. So for the pseudocodes, we'll explain much more detail in the later sections. So this is like a map here for what we're going to do next sections. So this is a correct programs here. So when the user key in the keys here, they also key in the plaintext. This is what the ciphertext will be generated. So first we have to get the key from the user. So this is the default program. So the user will key in this. So after the user key in the keys, we have to validate the keys in 3 conditions. First, we have to make sure this is 26 characters. For example, there's only 5 characters, so this is not accepted. So for the second conditions, it must have all letters. So you can see here there's 3 digits here, so this is not accepted. It must not contain repeated characters. As you see clearly, there is 2 repeated J here, which is not accepted. So these 3 conditions help us to validate the key here. So after that, we have to get the plaintext per user for plaintext. So this is the key, this is the plaintext. After that, we have to go through the Encipher process. So Encipher process also divided into 3 categories: The first, we have to make sure the characters are letters and uppercase. For example, this is CS50, and also we pick it up from here. So uppercase is TCS, the letters and lowercase is HISIS, not letter is a 2 space here and 1 dot here. So this is not letters. So after we divide here, we can do some conversion here. We explain much more detail in the later sections. After that, after we do all this, so we print the ciphertext here. So we have to print a new line here too. So first we have to get the key from the user. So the user have to provide exactly one command line. So the user must not provide no command line and also 2 or more. So if they provide no command line 2 or more, we have to show a statement to the user. For example, this statement. So the usage./substitution key. So we can use the method of the if-else methods. If a true conditions, so we continue our program here, else we will print this. So we can see again, we go back to the basics. So this is argv0, argv1. So we must have these two, which means the argc is 2. Okay, so we go through the validate keys. So as we explained earlier, the key must contain 26 characters. All letters must not contain any repeated characters. For example, if the user key in this, will be rejected because it only contains 5. So if the user key in some digit here, so it will be rejected too. So there's any duplicates characters also be rejected. This is what we want with 26 characters here. This is what we fulfill it. So we go through the first one, which is must consist of 26 characters. So we can use a method called string.h, string length. So what is this? This is a string x. So as we just now, what we remember here, this is argv1. So we use this as string x. So this will be rejected, it will be fulfilled. So the program will be something like that. We have to include the string.h, string length argument vector 1 not equal to 26. If they are not equal, we have to print these statements to the user. Key must contain 26 characters, return 1. So next, must be all letter. So we have to check the characters, make sure all of them are letter. We can have a method like a global variable. We put here the variables count key character equals 0. Then the for loop, string.h, string length, c types is alpha, if else. So the concept here is to compare the global variable with string length. If tally is passed, if not tally, we fail. So if fail, we have to print these statements. The key must only contain alphabetical characters. So this is like a program here. So if the user key a digit here, so the global variable will not count these 3 characters here. So it means there are only 23. So the string length is 26. So we can see it's not tally, so which is fail. So the program will print this statement. Next, the same one, we will go through a more detailed program. So must include the string.h, the c type.h. So this is a global variable equals to 0. A loop here, string length. So the string length here is to loop through this argv1. So when we look through here, we have to check one by one whether it's alpha, means whether if this is a alphabet. If E is an alphabet, we'll add one count here, so which is plus plus. So you can see we'll count 1 to 1 to 1 character next to it. So we'll not count these 3 characters, which is a digit, so it doesn't pass here. So after we count, we will get this value 23. So you can use the if or else if. So we can use this like conditions. If the count key character is not equals to the string length argument vector 1, so this will be a fail. When it fails, the program will print this statement. So which is wrong. Okay. So next we will go through this must not contain repeated characters. So we use a method, the same methods, similar methods, global variable, count repeated characters equal 0, a for loop, a string.h, string length, C types to upper to lower. If else, then we have to compare this global variable with the initial global variable value. So if equals to 0 is pass, if not equal to 0, fail. If fail, the program have to print a statement. The key must not contain repeated characters. So this is an example here. You can see there's a duplicate J here. So once there's a duplicate here, the global variable will count this as one duplicate. So the initial value of the global variable is 0. So it's not equal, it means fail. So this is what we want, there's no duplicate, which is correct. So this is a much more detailed code, include these 2 libraries. Global variable equals to 0. So first we create a loop, first loop. J equals to 0, string length argument vector 1. So this is like a normal loop here. So inside here we have another loop. So you can see the J here, this is the first loop. This is a second loop. So K is equals to J plus 1. So this is 0, 0 plus 1 is 1. So 1, 0 is this is 1. So K 1 is this. So the second one. So we start the index from the second one. So you can see this J is 0, the K is 1. So we compare these 2 values. So the first one is J, this is J, and compare with argv1k, which is this. So we convert both of them into lower. So for example, there's a mixture of uppercase or lowercase. We'll force them into one same case. So you can see there, we'll compare the J with T. Then we'll compare J with R. We'll compare the J with E. And so on to J, another J here. This is how we find another J duplication here. So when we complete the K25, we'll go to the other J is equal to 1. So it means we will start from T, then the K is K2, you start from R. So TR and TE and TK and so on. Then next the J2, so we become R compared with E, R compared with A, K, R compared with Y. So this method will check every characters, make sure there's no duplication here. So if there's one duplication here, they will print add 1 here, or 2 duplicate 2, and so on. So if there are any duplication, the value here will not become 0. So we can use this as a condition. If or else if the count key character is not equal to 0, means this is not what we want. So the statement will print key must not contain repeated characters. So substitutions, you can see this as an example. So there's a duplicate J here. So the count key will plus 1. So we can see it's not equal to the initial variable. So which 0, which fail. This is what we want, there's no duplication. Next we will go through the plaintext. So this is very common, very similar from the previous. We just have to add the CS50.h getString, decline a variable getString. So this is how we prompt and store the user plaintext. So Encipher, we have to understand the process. For example, this is the original letters A, B, C, D, E to Z. So substitutions, J, T, R, and so on. So you can see the A is actually equals to J, B is equals to T, C is equals to E, C is equals to R. So on and so on. So for example, if the plaintext A, B, 50 and exclamation marks, so these three, when we will not look at it, it will remain the same, you can see. So the A here, this will be something like A equals to J, B is equal to T. So this is how the program should work. So to detail much more clearer, so the ANSYS plaintext AB 50 exclamation mark. So convert into decimal, there's a number value for each of the characters. Uppercase for A is 65, lowercase is 98. And unknown alphabet 50 exclamation marks is 50, 48, 33. So we use this formula here, depend on which case is it. So we convert here, we get the letter sequence. For example, the sequence is sequence. But once we get this number here, so we know this is 0 and this is 1. So we convert back using the to upper and to lower function, library, some function. So we'll convert back to the original plaintext case. So this is how we go through here, how the process go through. So for the Encipher, the goal will be iterate over one by one of the plaintext, divided into 3 categories: uppercase, lowercase, and others. So we can use the methods like a for loop, string.h, string length, ctype.h, is alpha, is upper, is lower, to upper, and to lower. So this CS is a ciphertext sequence. So the P is a plaintext minus the case, depend on which case is it. Is uppercase is 65, lowercase is 97. So after we get this sequence, we will plug into this C equals to upper or to lower argv1 CS. This value will plug into here. So we take a look on the example here. So for example, AB is the key. So AB here, we will divide it into 2. Uppercase CS equals to 65. This is the original. So this is the formula, 65 equals 0. CS 98 minus 97 equals to 1. So once we get the sequence here, no matter what is the key consists of uppercase or lowercase, we just want to get the characters. So we also will convert them back according to the plaintext case. So it's J and T. So we combine them together into JT. So this is exact process how it works. So this is like a more detail. Include these 2 libraries. Create a loop here. The string length plain. So this will go through here. So I have the categories for letter and uppercase. This one. For this uppercase, lowercase, and not character, not letter. So if uppercase, we use the formula as we explained just now. Take a T for example. So a T will convert to a decimal. So a decimal number will minus 65. So we get the sequence number to this upper. Once we get the sequence number, we'll plug into this here. So we will find which sequence is it. For example, this is T. It will be here. So this L, for example, this L is is a lowercase, so we force them into uppercase. So that's why you can see the result is a uppercase L. So using this concept, you can form your own formula for the lowercase, and slightly different for different way for categorize for non-letter, not letter. So after that, when we divide them, we get some result here. We have to remember to print a new line here, return 0. So this is combinations of 6.1, 6.2, 6.3, and 7.1. So that's it. Thanks for watching, and I hope those tips will help you to solve the problem more easily. Please subscribe to my channel, Conscious, and see you soon.